Hello, I'm Andrea, one of the Directors of Research Ecosystem at ARM and host for this session on research collaborations, where I'm going to highlight some of the different ways that we work with academia and the benefits of doing so, for both us and hopefully for you. I'm also going to be joined by two of my colleagues who will talk through specific examples of existing collaborations where we are working with universities and other partners to generate exciting new research outputs with real-world applications relevant to the global challenges. But more of that later. As many of you will already know, collaborations and support for the research community are key activities for us. Indeed, one of the driving motivations behind the Research Summit is to make ARM staff, our research and our technology more accessible to all of you by providing plenty of opportunity for networking and discussion alongside the technical talks. So little could we have imagined when we started planning the summit late last year that we would be in the virtual situation that we now find ourselves in, with the space to make those valuable informal contacts and linkages severely curtailed. However, even though the event we now all find ourselves attending is rather different to what it would have been otherwise, we, as ARM, wanted to emphasise to you that academic collaboration continues to be an incredibly important part of our research strategy. In fact, as we raise our horizons to consider the part that technology can play in addressing global challenges such as sustainability, societal needs, and security, it is clear that an open and collaborative approach is essential to drive the innovation required to generate workable solutions, something that has itself been made explicitly clear by the coronavirus pandemic. And as we move forwards, ARM is therefore striving to make sure that we continue to be the partner of choice for you, and that the connections we make have a positive impact for both of us. The left-hand side of this slide summarises the different potential benefits that a collaboration with ARM could bring. I'm not going to go through the list in detail, but I thought I would call out two things in particular and add one of my own as well. Regarding the first item on the list, we've always provided ARM IP and technical support to the academic community, but in response to feedback from you, this year we launched the ARM Flexible Access for Research, or AFAR programme, which makes it quicker and easier for you to undertake research on ARM technologies, including full RTL for a range of Cortex-A, Cortex-R and Cortex-M CPUs, Mali GPUs, tools and subsystems. My colleague Richard summarised this in his presentation yesterday. If you missed it, there's more information on the ARM website, or head over to the enablement pod in the Get to Know ARM Research breakout area on the main summit website. And at the bottom of that left-hand list is another example of how we're responding as a partner. We also now have a dedicated team in place to manage and respond to academic inquiries and to support active collaborations. We hope this makes us easier to talk to and more responsive. I certainly do, as that's my own role for the European region. The list of how we can offer support on the right-hand side is not meant to be exhaustive, so please do reach out to us to discuss your project and how we could usefully support you in the first instance. But all of this seems a bit one-sided, particularly as collaboration by definition involves working together. To ARM, collaboration with you brings value through joint publications, early access to research results and to academic thought leadership, insights to support our own lobbying to funding agencies and policymakers on all our behalves, and the ability to contribute to education and training of the next generation of researchers and industry employees. And it also helps motivate our own staff, who place immense value on the intellectual stimulation they get from talking to and working with you. All of this is best illustrated by putting it into context with some specific examples. First, you're going to hear from my colleague Eric van Hensbergen about how lessons learned from an internal-only project led directly to a new collaboration that he and his group have been involved in, and where the combination of ARM infrastructure expertise and domain-specific research in an iterative development model is leading to positive environmental impacts at a citywide scale and beyond.
Hi, my name is Eric Van Hensbergen. I'm an ARM Fellow and the head of the Software and Large-Scale Systems Group here at ARM Research in Austin, Texas. I'm going to talk to you a little bit today about some of the collaborations that we've done. I'm going to start by talking about a project where we didn't have partners we collaborated with. And this was a proof of concept project that we had across the different skill groups within research, trying to build an edge device for healthcare. Now, I'm not going to go into the details of this project, but because we didn't have any partners, we spent a lot of time thinking about potential use cases and building applications for a healthcare market, which ARM doesn't currently service. ARM isn't a provider of applications or application services, and we spent a lot of time building applications in a domain that, frankly, we didn't understand very much about. So a couple of years ago, we decided to try and take some of the infrastructure that we built for this healthcare project and partner with external organizations to identify use cases, provide applications, and allow us to focus on building infrastructure and providing hardware for their use cases. This led us to a collaboration with Northwestern and several other universities, along with Argonne National Labs. Now, Northwestern and University of Chicago and Argonne have had a Smarter Cities project in the city of Chicago since 2014. It's called the Array of Things. It's built out of ARM hardware, and they actually have 150 of these pods that you can see up here deployed across the city, and then they're running various machine learning and other analytics at the edge, collecting data from cameras and microphones, weather sensors, and so forth. And they do a bunch of the processing at the edge because they backlink to the data center over cellular connections. So video and audio never leave the device. Only metadata, after it's processed by a machine learning algorithm, leaves the device. So it's a great edge computing example. They built their entire stack from scratch, and they had a number of different applications that they ran on the device. And so this was a great wealth of applications and real-world use cases with a real-world deployment for us to base a proof of concept around, built by building a next-generation system. And this was all sort of perfect timing because that same team was just spinning up the next version of their project, which they called Sage, where they were looking to build out into a wider range of environments. So besides smart cities, also looking at rural environments to do environmental monitoring, to look for wildfires, to track wildlife, and to track global warming. And so in this new project, they had many more collaborators. And what they really wanted to move towards was a better multi-tenant platform where they could more easily switch the analytics that were running on the edge devices in a much more fluid way. The original devices were somewhat hard-coded. They load them up, and then they just kind of ran those applications. And they had ways of updating them, but it wasn't as convenient as they would like. And what they wanted was to move to a more cloud native sort of environment. And this is exactly the sort of infrastructure we had built in the healthcare project. So we started talking to them about Smarter, which was a cloud native environment that we had built for the edge for the healthcare project. And since all of their code was open source, we actually were able to pick up their applications, including their ML applications and their sensor applications, and port them to a containerized environment, deploy them with Kubernetes to the edge using our infrastructure, and then take it back and show them what we had done. And they got very interested. And this has led to a very tight collaboration where we're providing bits of infrastructure to them based on use cases and requirements and applications from their original project. and iterating on designs with them on a weekly basis, where we get real-world user feedback, real-world developer feedback, and so we're not operating inside a vacuum, and this has been incredibly useful. And so the way that we structure these different collaborations is that on the Smarter project, we started off by having a new policy of open source by default, where historically we would do the research, and at the end of the project, we might open source the resulting software. In this project, we decided to put everything in the open right away, and any new software to develop, we'll start with it already in the open, and this has made it a lot easier to collaborate with partners because they can directly access software while we're developing it. And we do this by putting everything on GitLab. We have CI/CD flows for everything. We're even putting all of our documentation, including our architectural specifications, in source code repositories as Markdown. And that way we can get early feedback from partners and iterate on concepts very quickly. In addition to GitLab, we have Slack channels that we use to collaborate with different partners and different deployments. So there's the Northwestern project, but there's also 5 other projects. And for each one of those, we have some means of Slack communication with them, and that gives us a very interactive, extemporaneous way to exchange ideas, hear about problems, hear about opportunities, and communicate with the partners. In addition to those, with several of the collaborations, we do have regimented conference calls with Northwestern. We're meeting with them every week, doing deep dives on new ideas, talking about gaps, talking about problems, and talking about new solutions that we can work on together. With some of the other partners, it's every other week, sometimes once a month. It really depends on the nature of the collaboration and kind of how to spread in those different environments. And the whole thing ends up being very cyclical. So we start with the requirements, we use those to develop a software architecture. That software architecture could be part of a platform standard that we can go and push within the broader ARM, or we could just use that to build our prototypes, and then those prototypes become part of the ARM library of reference designs that we share with academic partners as well as commercial customers as starting points for their own projects. Then that prototype becomes a platform which the partners can target with their applications, whether it's a port of an existing application or a new application written against the platform. And hearing about their experiences, whether it's porting or writing a new application, gives us great feedback that we can provide into our team as well as product teams as we're using lots of libraries and tools from the product teams in the development of the prototype. And then, of course, we get the experience of being tightly tied into a real-world deployment, where we get all sorts of new gaps identified around reliability and security and performance and efficiency. And then we can use that to generate new ideas for not just how we can make the software infrastructure better, but how we can make the hardware better in future generations. And then that starts the whole cycle all over again. And so if you're interested in learning more, the top 2 links here are for Array of Things, as well as the SAGE project, if you'd like to hear more about what our partners in Chicago are doing. If you're interested in learning more about Smarter, you can go to getsmarter.io. That has blogs and webinars and documentation, publications, and of course the source code. And there's also images you can download there to deploy onto a Raspberry Pi or a Jetson board and try it out for yourself. Additionally, there's links to 2 ARM products which we're incorporating into this design. Project Cassini is a ARM Edge Gateway reference design, which we're really building on top of. And it's very focused on the system layer platform abstractions, as well as the security APIs for how you talk to the secure elements on ARM hardware. And so we're providing feedback on both of those things from our partners' experience to those product teams. And then finally, Armpellion Edge is the gateway management system as a service that Armpellion provides. And we're utilizing that for software updates of the platform. So thanks very much for your time and enjoy the rest of the summit.
Thanks, Eric. So that's one example of how we're working in close partnership to deliver real-world impact within relatively short timescales. It also neatly indicates our commitment to open source development, recognising that it facilitates both the collaboration itself and the scale and speed of those resulting impacts. And if any of the projects that Eric highlighted at the end there are of interest, please do look those up and see how you can get involved. My colleague Emre Ozer is now going to talk us through how collaboration with a range of academic and industrial partners is developing an ML compute engine within a flexible electronic substrate for a rather interesting use case in the first instance.
Hi, my name is Emre Ozer, and I've been with ARM Research for 15 years, and I'm going to talk about our collaborative research project, PlasticArmPit. So what is the project about? It aims to develop a system that senses odor, digitize it, and then predicts its intensity. All three components put together to make a disposable strip like this that can go to your underarm and score how bad your odor is. The problem may sound trivial and be solved putting together off-the-shelf electronic components. However, our goal is to develop this disposable strip without using any bulky and expensive electronics. Instead, we focus on developing these components using flexible electronics technology. Flexible electronics technology uses low-cost materials such as plastic or paper, and its fabrication is a lot simpler than conventional semiconductor fabrication techniques. The flexible ICs manufactured cost cents, not dollars. Besides, they are extremely thin, bendable, and conformable. The project has 4 partners. ARM is the lead partner, and other partners are Pragmatic, Manchester, University of Manchester, Unilever. And the project is funded by Innovate UK, UK government's funding agency. The Unilever brings the use case from its deodorant business sector. University of Manchester, ARM, and Pragmatic are the technology developer partners. Manchester develops the electronic nose sensors based on the organic TFTs, and they manufacture them on flexible substrates, on plastic like this. Pragmatic fabricates flexible ICs using their own unique fab-in-a-box production line. They also developed the sensor readout interface in the project. ARM designs and implements the compute block in the project by developing a flexible machine learning chip. But the Pragmatic is the partner that fabricates it. All 3 partners collaborate on the system integration. We have a small flexible electronics research team at ARM. What we do varies from standard cell libraries to all the way to algorithm development. So we do hardware design and optimization of the compute block, and we also do the chip implementation. For everything else, we collaborate with others, whether it's a system integration or flexible electronic device material development, flexible electronic fabrication, and other component developments such as sensors and harvesters and ADCs, etc. We collaborate with other partners. We had an extensive media coverage of the project in the first year to increase the visibility, thanks to our marketing team. So the media coverage ranged from the tech portals to newspapers and magazines. We had our key outcome this year in 2020. We built the very first ML chip on a flexible substrate, and we tested and validated. We also published it in the July issue of Nature Electronics, which made it to the issue cover as well. So the value of collaboration for ARM. So I think the first thing is the complementarity. What does this mean? So this means that we can't do everything on our own. We have to collaborate with others to learn from their expertise. For example, in the PlasticArmPit project, we learn about the use case from Unilever, as well as we learn a lot about the electronic nose sensors manufactured on flexible substrates using organic TFTs from Manchester University. And the second thing I would say is these type of collaborative research projects strengthen the relationship between the company and the academic partners. So typically there are frequent academic visits to the company and getting interns from the universities. But in the PlasticArmPit project, we had a unique opportunity to get Professor Gavin Brown of machine learning from University of Manchester to work for ARM as a part-time visiting professor. This allowed us to learn about the intricacies of the machine learning algorithms and the evaluation methodologies. Visibility, so these type of projects, in particular the ones that are externally funded, allow us to disseminate in external events, and the projects become more visible in the external domain. So this is this is different in comparison to the internal confidential projects we typically run in industry. And the final point is the crossing interdisciplinary boundaries. So perhaps not in every collaborative research project, but in some collaborative research projects, you have an opportunity to interact with other disciplines than computer scientists or electronic experts. For example, in PlasticArmPit, we had to learn about material science, organic chemistry, how to develop these ENOS sensors, plastic ENOS sensors, using the organic TFT technology, etc. Having said that, the collaborations with other disciplines may create some terminology issues where a particular term is used in every discipline, but everybody understands differently. The good example is the word data. When you talk about the data, every discipline understands differently. Please feel free to contact me if you want to know more about the PlasticArmPit project or about any future collaboration opportunities related to flexible electronics. Thank you very much.
Thanks, Emre, for another great example of a collaboration vested in complementary strengths, and for additionally highlighting the benefits brought by moving out of our own comfort zones and crossing interdisciplinary boundaries. Of course, the longer-term outcome of the PlasticArmPit project is that low-cost nature of these chips and their bendability means they could be used to build a much wider range of smart devices than is possible with current conventional electronics. Other potential applications include integration into plastic wrappings to process the odour profiles of packaged foods in order to determine shelf life and safety to eat, or incorporation into smart bandages to provide an early indication of wound infection. Whilst it may take time for products to come to market, it's clear that this combination of advanced processing capability, flexibility and low cost could have a wide range of societal impacts. Again, if this has sparked some ideas of your own, please do contact Emre via the details he provided at the end of his talk. And in this afternoon's technical session, you'll hear more about how a long-term collaboration with the Universities of Cambridge and Edinburgh on capability architecture, now supported by funding from the UK government, will hopefully lead to a safer digital future for all of us. The Morello prototype board generated by that project will be widely shared, enabling academic and industrial research into the true value of capabilities with respect to security, in a true collective effort. And we are already supporting a number of successful proposals under the aligned EPSRC Digital Security by Design funding call. So if all of that has raised questions or queries, or you just want to find out more, head over to the Collaborations pod within the Get to Know ARM research area in the breakout zone. There's also the opportunity there to enter into a live Q&A with me or one of the team. Alternatively, you can fill in the inquiry form on our website or reach out direct. We'll do our best to align you with an appropriate technical contact for further discussion. I do have one small ask though. Please do contact us early to enable this matchmaking to happen and for us to jointly develop the most appropriate means of support well in advance of the all-important deadlines. You may have your own submission deadline, but we also have internal processes to go through. To conclude, thank you for joining us for this overview of ARM research collaborations. I look forward to hearing from you with proposals as to how we can work together to increase the impact of all of our research.